Hey everyone! So you're about to hit that chapter on the t-test in your stats class. And when you see the formula, it's easy to think it's just a bunch of math, but it's actually so much more than that. It's a powerful tool for answering one of the most basic but most important questions in all of research.
And that question is simply this. Are these two groups actually different, or did I just happen to get a weird sample of people? Is it a real effect, or is it just random chance? This is the fundamental mystery that a t-test is designed to solve. It helps us find a real signal in all of that statistical noise. Think about it this way. Let's say you're testing two different study methods. Group A gets an 85% average, and Group B gets an 88%. Okay, so method B is better, right? Well, maybe, but is that 3-point difference really meaningful? Or is it possible that if you ran the test again with different people, method A might come out on top? That little bit of doubt is exactly why we need a tool like the t-test.
And that tool, of course, is the t-test. So let's dive in and break down what exactly it is, and more importantly, what it tells us about our data.
All right, here's the official textbook definition for you. A t-test is a statistical test used to see if there's a significant difference between the averages, or the means, of two different groups. And that word, significant, is really the key here. It's the statistical way of saying that the difference is probably real and not just a fluke.
What's cool is that a t-test actually tells you three distinct things. First, it gives you the direction. Like a compass, it points to which group's average is higher or lower. Second, it gives you the magnitude. It tells you how big that difference actually is. And third, the most important part, is the significance. This is what helps us decide if the difference is a real pattern or if it could have just happened by dumb luck.
Now you should know there are a few different types of t-tests out there. But the one we're going to focus on today, and honestly the one you'll probably see the most, is the independent samples t-test. It's the perfect tool for when you have two completely separate, independent groups of people, like say mothers compared to women without children, and you want to see if they differ on some measurement.
Okay, enough theory. Let's get our hands dirty. We're going to walk through step by step how to actually run one of these tests using a free software called PSPP.
First things first, you gotta find the test itself. So you're gonna go up to the Analyze menu, click on that, then go down to Compare Means, and from there, you'll see Independent Samples t-test. Pretty simple so far.
Next up, this box will pop up. You need to tell the software two really important things. The test variable is the thing you're actually measuring. In this case, it's a score on a scale of marginalization. Then, the grouping variable is, well, it's what creates your two groups. For us, that's the motherhood variable.
But wait, it's not quite enough to just tell it motherhood. The software needs to know exactly which two groups to compare. So you have to click that Define Groups button and tell it, okay, for Group 1, I want women with children, and for Group 2, I want women without children. You have to be specific.
Now, let me give you a huge piece of real-world advice that comes straight from the source material. This program can be a little buggy, and the t-test function is famous for crashing. So here's the tip. If you need to change your variables, do not use those little arrows to move them back. You have to click the Reset button first. I'm telling you, this will save you so much frustration. Just trust me on this one.
All right, so we've clicked OK, we've run the test, and now we get a big table full of numbers. I know, this can look a little intimidating at first, but we're going to break it down and find the actual story that's hidden inside this output.
And here it is, in all its glory. The full output table. And yeah, there's a lot going on there. But here's the good news. You really only need to pay attention to a couple of specific numbers to get the whole story. We can pretty much ignore all the rest and just zoom in on what matters.
So let's start with the most basic finding. The bar chart shows us the average scores for our two groups. We can see right away that women without children, on average, had a higher marginalization score, 6.43, than women with children, who had a 5.65. So there's a difference. But how big is it?
The output table literally tells you. It calculates the mean difference for you. In this case, it's negative 0.79. That's our magnitude. It puts a specific number on the size of the gap between these two groups.
And now for the magic number. This is the p-value. You'll find it in the column labeled SIG two-tailed. Think of this number as your fluke detector. It tells you the probability that you'd see a difference this big just by pure random chance. And our value here is 0.002. That's really, really small. And this brings us to the punchline. In social science, the magic cutoff number is usually 0.05. If your p-value is less than 0.05, you get to call your result statistically significant. Well, our p-value is 0.002, which is way smaller than 0.05. So we can say with a lot of confidence that this difference we found, it's not just a fluke, it's a real finding.
But hold on, a good researcher never stops at the first answer. Okay, so we've found a significant difference, but is motherhood the only thing going on here? Could there be another factor, maybe something like education that's playing a role? This is when we have to start digging deeper.
And a fantastic way to do that is with a feature called Split File. Basically, this tells the software, hey, run that exact same t-test you just did, but do it separately for each educational group in my data. It's like running 3 different studies all at once.
And would you look at these results? This is fascinating. The table shows us that the significant difference we found between mothers and non-mothers, it only shows up for the group of women with a high school education or less. For women with an associate's degree or a bachelor's degree, the difference completely vanishes. It's not significant at all.
This is why we dig deeper. The whole story just changed. Our first finding wasn't wrong, it was just incomplete. It turns out the relationship between being a mother and feeling marginalized isn't so simple. It seems to really depend on a woman's educational background.
Which brings us to a final thought for you. We've just seen how education can completely change the story. So what other factors might be at play? Now that you know how the tool works, think about it. How would you set up a test to see if a person's age has a similar effect? The questions are endless, and that's what makes this so exciting. Now you're ready to not just read about the research, but to start thinking like a researcher yourself.